Okay, so I am recording right now, and this is a review on section 9.1, and it's the section on graphing parabolas that are in standard form quadratic trinomial equations, right? And there are so many types of questions that I could ask you just on one equation. So let me go to this one right here. I could give you this equation, and I could ask you, does it have a maximum value or does it have a minimum value? That is correct. It is a maximum value. And again, just to reiterate, this a value is negative. If the a value is negative, your parabola will open down. If the a value is positive, your parabola will open up, right? If the a value is positive, hey, happy face. If the a value is negative, oh, you're a negative person, sad face. Okay, that's probably, let me just delete that. But yeah, the a value tells you if it opens up or down, which will determine whether you have a maximum value or a minimum value. Maximum value, like if you were to throw something up in the air, goes up, 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 then it reaches a max height, and then it comes back down. That's a parabola that opens down. That's a parabola that has an a value that's negative. That will produce a maximum value. If you actually wanted to find that maximum value, you would find the vertex. The vertex is either the highest point or the lowest point of a parabola, depending on whether it opens up or down. And you could determine whether it opens up or down by looking at your a value and seeing if it's positive or negative. So I hope we all understand that. I mean, that in itself, I could ask you a couple of questions, right? Does this have a maximum? Does it have a minimum? Does it open up? Does it open down? Not only that, I could also ask you which function is wider, all right? If I say f of x, or let's say g of x better instead of f of x. G of x is just the name, and let's say I had negative x squared. I'm sorry, here we go. Negative x squared. That is a parabola that opens down. If you compare this g of x that has a negative 1 as an a value compared to the negative 2 on the f of x, which one is wider? Which one is wider? Is it the g of x or the f of x? Which one is wider? Go ahead and type in g or f, okay? Which one's wider, the g function or the f function? At the count of 3, we're going to hit enter. 1, 2, 3. Which one is wider? And I'm going to check the comments, and it looks like F. You guys are saying F is wider, and there's some question marks. And you know what? I appreciate your responses, your engagement. Why? Because we are now able to talk about what the real answer is. Which one is wider? This one is wider. Now, why is that? Let's actually do a quick little mini lesson here on which one is wider, okay? Well, let me do this. Okay, guys, so if your a value is 1, here's the parabola y equals x squared, the parabola y equals x squared. If I compare that to y equals 2x squared, it gets narrower. Okay, again, y equals x squared, y equals 2x squared, it gets narrower. Y equals x squared compared to y equals 1/2 x squared, it gets wider, okay? So the a value, the y equals ax squared, that a value determines if it's wide, if it's narrow, if it's opening up or opening down. We should know that if the a value is negative, it opens down. If it's positive, it opens up, right? But let's compare y equals x squared, so regular U-shaped curve. Y equals x squared compared to y equals 2x squared, y equals 3x squared. It gets narrower as the a value gets further away from 0. Y equals 1x squared, 2x squared, 3x squared, 4x squared, 5x squared, right? Y equals 1x squared. If I get closer to 0, it gets wider. Y equals 1/2 x squared, y equals 1/4 x squared, y equals 1/10 x squared. It's getting really close to 0. If it actually got to 0, if it said y equals 0x squared, it would not be a parabola anymore. It would be a totally flat line. So I hope that helps. And I'll tell you guys, this will be a question on the test. Which one is wider? Okay, so I hope that kind of made sense. So let's look at this. What if I had y equals 2x squared compared to y equals 5x squared, okay? Which one is wider? Is it, and you know what, let's call this one, yeah, I apologize. Let's do this one, let's call it f of x. And let's call this one g of x, okay? So which one is wider? The f of x or the g of x? Which one is wider? The f of x or the g of x? Type it in right now. Count of three. 1, 2, 3. Boom. And absolutely right. Thank you. Most of us are putting f of x. That one's wider. And if you put g of x, it's okay, right? The fact is, 2, when you stretch it to 5, it gets further away from 0, so it gets narrower, okay? The closer it gets to 0, it gets wider. So the wider parabola here, this one is wider. This one is narrower, okay? If I compared f of x, if it were like a 1/2 x squared compared to g of x, which is a regular x squared, then this one would be wider because this a value is closer to 0. 1/2 is closer to 0 than 1. So the one that's closer to 0 will be wider. The one that's further away from 0, I'm talking about a value here, will be narrower. So I hope that makes sense. So those are all questions that I could ask. But let's now start asking questions specifically about this f of x equation. I could ask you for the axis of symmetry. Okay, now you need to know that the axis of symmetry is that vertical line. I usually draw it in green dotted line going right through the vertex, right? So if I'm asking you for the axis of symmetry equation, you obviously need the vertex. So indirectly, I'm asking you for the vertex because you need the vertex to be able to state the axis of symmetry equation. So let's all write down vertex. That is a coordinate, and we find that coordinate by using the vertex formula x equals negative b over 2 times a. And when we use that formula, let's use parentheses in order to plug in the b value of negative 4 and the a value of negative 2. So b is negative 4, you plug that into the top. A is negative 2, plug that into the bottom, and now simplify the fraction. You have a minus 4, which changes to a positive 4, and 2 times negative 2 is negative 4. So what we end up with is x equals positive 4 over negative 4, which means that x equals negative 1, okay? And what did we just find right here with this formula? With this formula right here, we found that x equals negative 1 on the vertex. Now, believe it or not, if you're trying to find the axis of symmetry equation, all you need is that x value of your vertex. X equals the x value of your vertex. Ta-da! Axis of symmetry. You're done. Simple as that. Okay? Once again, axis of symmetry equation will be x equals the x value of your vertex. Now, some of us are going to just say, oh, the answer is 1. You can't just say 1. You have to say x equals negative 1. Negative 1. You can't just say negative 1. You have to say x equals negative 1 because that's what produces a vertical line at negative 1. Okay? So another question, so that's one question, find the axis of symmetry. Another one is find the actual vertex. We already know the x value. When you want to find the y value and you already know the x value, all you have to do is plug it in, right? It doesn't matter how simple or complicated the equation is. Like if I had x plus y equals 3, and I tell you, hey, x equals 2, how are you going to figure out what y is? All you do is plug in the 2 right there, and you will clearly see that y must equal 1, right? So it doesn't matter if it's a complicated equation or a super simple equation. If you know your x value and you want your y value, all you have to do is plug it in. So we know our x value of negative 1. Let's plug in that x value right there and right there. So the safest thing to do would be to rewrite it, but put parentheses instead of x's. That way you could plug in your x value of negative 1 right in there and right in there. And when you do the math, negative 1 squared is positive 1. And when you do negative 2 times positive 1, that'll be a negative 2. And then this will be a positive 4 and then plus 6. Why positive 4? Because negative 4 times negative 1 is positive 4. So you really have a negative 2 times 1, which is negative 2, plus 4, plus 6. That will give you 8 as an answer. And of course, this is saying y equals 8. So your vertex y value is 8. I apologize for the work being kind of ugly, but that's your vertex, negative 1, 8. And you could graph it, negative 1 on the x, 8 on the y. That's right there. 1, 2, 3, 4, 5, 6, 7, 8. Yep. You could draw your axis of symmetry right through it. So just to reiterate the types of questions I could ask, I could give you this and I could ask you, do you have a maximum or minimum? I could give you this and I could ask you, what's the axis of symmetry? I could give you this and then ask you, find the vertex, right? I could give you this and ask you, what is the domain? What is the domain, right? Go ahead and type in what you believe the domain is, and at the count of 3, we're going to hit enter. 1, 2, 3. The domain is, thank you, Kimberly. Thank you, Angel. All real numbers. Thank you so much. And we have to put x equals all real numbers. You could either spell it out, all real numbers, or you could use the symbol, that R. Actually, you have to spell it out because you're typing it in the chat right now. So yeah, the domain is x equals all real numbers. That is true for any parabola. It doesn't matter if it's wide, if it's narrow, if it's opening up, if it's opening down. Your domain will always be x equals all real numbers. Now the range is a different story, because the range are no longer your inputs, they're no longer your x values. The range are your y values, they're the outputs, right? And this parabola will not go up forever and down forever. We know that it opens down, so it does go down forever, but we know the vertex is a maximum value, so we know that it doesn't go above this vertex value. So even though we don't have the parabola drawn right here yet, we could still understand that the a value is negative, which means it opens down, which means this is a maximum value, which means that the y values of this parabola will be at this maximum value of y and below. All right, it'll be at this maximum value of y and below. What is this value of y? That's the value of 8. And of course, you could clearly see that because it's the y value of your vertex. Okay, so this y height is the y value of 8. So when we're talking about the range, we're going to say y has to be at 8 or below. So that's going to be less than or equal to, why is it yellow? Sorry. Less than or equal to 8. There's your range. I mean, so seriously, guys, there's tons of questions that could come out of one quadratic trinomial equation, right? Find the axis of symmetry, find the vertex, find the domain, find the range. Do you have a max or min? Does it open up or down? Man, that's already like 6, 7 questions, right? What else could I ask you? I could ask you to identify which is the correct graph. So we need more coordinates to graph this thing. And we do have 2 options. One option is to use an input-output table, your traditional XY table, by plugging in numbers for X and pulling out answers for Y. And those do give us coordinates, which we could graph on this XY plane and then reflect to the other side of that axis of symmetry. Or if you have the pattern memorized, when your a value is 1, you could use the pattern 1, 1, 2, 4, 3, 9. Now the problem with the pattern, well, it's not really a problem, but the thing that you need to recognize is that the a value is not 1. The a value is -2, right? So we need to modify this pattern because this pattern is strictly for a value of 1. And what I need to do is modify it to become a 2. Now, I could have put a -2, but the bottom line is the negative means that it's going to be opening down. So if you want to put a -2, that's fine. Or if you want to just put a regular 2, that's fine. Just remember that you're going to be going over and then down, okay? Because it's opening down. So anyway, how am I going to change this pattern to the new a value of 2, modify it with the a value of 2? All I'm going to do is multiply right there times 2 multiply right here times 2, multiply right here times 2. What I'm doing is multiplying the outputs of the original A equals 1 pattern to get new outputs. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. So now, instead of the pattern being 1, 1, it's going to be 1, 2. Instead of the pattern being 2, 4, it's going to be 2, 8. Instead of 3, 9, it's 3, 18. Okay? So 1, 2, 2, 8, 3, 18. There's your new modified pattern for that new A value of 2. So again, from the vertex, you're going to go 1, 2, and we need to remember that it's negative, it's opening down. So 1 over 2 down, we get a dot right there. Then you go back over 1, 2, right? 2, 8, right? 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 right there on the x-axis. And if you go back to the vertex and try 3, 18, you're going to be way off the graph. So we don't have to worry about 3, 18. All we need to do now is map them over to the other side, and we will get our other coordinates right there and over here. And voila, we are done. We have a nice, beautiful parabola that opens down. And yeah, that looks slightly narrower than a regular parabola with the A value of 1, right? Because the A value of 2 is further away from 0, so it does get slightly narrower. I hope we understand how we modified the original A equals 1 pattern of 1, 1, 2, 4, 3, 9. We modified it by this new A value of 2 by multiplying all the outputs by 2, getting us those new outputs 2, 8, and 18. Now let's say you're old school and you don't want to mess with the pattern, right? Let's say you're old school. I don't want to stick to input-output tables. You could do that. If you want, you could go to your XY table and plug in the nice number 0. That's easy to do. 0 squared is 0. 4 times 0 is 0. 0 take away 0 is 0. Plus 6 is 6. So there's one coordinate. You could also plug in the number 1. Let's plug in the number 1. What would happen? 1 squared is 1. Negative 2 times 1 is negative 2. 4 times 1 is 4. Negative 2 minus 4 is negative 6. Negative 6 plus 6 is 0. And you get another coordinate. Again, the input 0 gave us the output 6. The input 1 gave us the output 0. These are inputs and outputs. These are x and y's. These are coordinates. So if I go to the coordinate 0, 6, I get to that red dot. If I go to the coordinate 1, 0, I get to that red dot. I map them over to the other side. I'll get the same parabola anyway. So it's up to you if you want to modify your pattern of 1, 1, 2, 4, 3, 9 according to your new A value, or actually go with inputs and outputs. Now, I like modifying patterns. I think it's pretty easy to take my 1, 1, 2, 4, 3, 9 and just multiply the outputs by 2. But if you like plugging in and doing math, you could do that as well. So we have tons of questions that I could ask on this simple first equation f of x on number 12 right here. I could also ask you for, I just noticed it right now, I'm missing it. What is the y-intercept? Okay, and I hope we remember to find the y-intercept, we must set x equal to 0 and solve, right? Now, visually, I could already see the graph, and I already know that my y-intercept, here's my y-axis, it's going to cross right there. And that location is 0 on the x, 1, 2, 3, 4, 5, 6. So I already know my y-intercept is the coordinate 0, 6. But that's because I have the graph. Now, what if on the quiz tomorrow I don't give you the graph? What if I just, let me cover this up right here. What if I just give you the equation and I ask you to find the y-intercept? It's really easy to do because, ladies and gentlemen, the y-intercept of any standard form quadratic trinomial that has ax squared plus bx plus c is going to simply be the coordinate 0 on the x and c for your y. So in this case, the c value is 6, right? So you would put 0 for the x, 6 on the y. Really simple. The y-intercept, the location of where your parabola will cross the y-axis of any standard form quadratic trinomial, ax squared plus bx plus c, will be 0 and the c value c. Now you don't actually have to remember that per se, because all you need to remember is that you have to set x equal to 0. So if you want, go ahead and put a 0 right there and a 0 right there and do the math, right? You're going to have negative 2 x squared minus 4x plus 6, and actually plug in a 0 right there. And when you do the math, you'll see that everything ends up becoming 0 except the plus 6, and you'll get that output of 6 for the input of 0. So the y-intercept is 0, 6. I will ask you to find the y-intercept, and I might not give you the graph, so you'd have to know to set x equal to 0 and solve. But there you have it, guys. Those are all the possible questions I will ask. And again, I probably will be using the same functions over and over and over. Like, I'll give you this function right here, and I'll tell you, hey, find the axis of symmetry, and that'll be one question. And then I'll give you the same exact function on the next question, and I'll say find the vertex. And that's another point right there. I'll give you the same exact function, and I'll say find the domain. And that's another point right there. Same exact function, find the range. Another one right there. Same exact function, find the y-intercept, you know? Which pattern would you use on this one? And you'd be able to, that's another question right there. Or for the inputs 0, what's the output? That's another question I could ask. So all of these questions, there are so many questions that could come from one basic quadratic trinomial equation, and that's what will be happening on tomorrow's quiz. I apologize for this long lesson. It was only one question, but we really went into detail on this one question by asking so many other things about it. I hope this helps you, and I hope everybody does well on the quiz tomorrow.